Okay. So you've got the Canadian and the British person trying to sound enthusiastic. I was asked to explain AI and everything else that's happening in technology to an AI conference and not talk too fast and only take 30 minutes, so I'll probably manage 2 of those things. But I thought a good place to try and start is this great quote from Bill Gates from this time last year. In my lifetime, I've seen 2 revolutionary demos, the GUI and ChatGPT. This is as interesting for what he doesn't mention as what he does, which I'll come back to. But I think that's a good place to start in thinking about how excited everybody has become. If you are applying to Y Combinator, the biggest, most important tech incubator, and you're not working on generative AI, then all of your friends will point at you and laugh. That was about 70% of the current YC batch. On the other hand, most people outside technology are a lot less sure or a bit more hesitant. Something like 2/3 to 3/4 of people have not tried this. Something like half have never even heard of it. And only sort of 2, 3, 4% of people are actually converted into DAU so far. And this number isn't actually going up very much. That's a very kind of glass half full, glass half empty kind of analysis. On the one hand, quite a lot of people have tried this very quickly. On the other hand, it hasn't really stuck. No one's quite worked out what this is for yet. And I think that kind of reflects a general sense, 18 months after ChatGPT launched, OK, this is amazing, but it's not clear what it is yet, and we're trying to work out what happens next. And for the sake of this discussion, I've split that into 2 kinds of question. There's all the questions inside the tech industry, and then there's all the questions that matter to everyone outside technology. So starting with what everyone in tech is trying to work out yet, to begin with, everything is still changing. The science is still moving. We don't know what this is going to look like in 6 months or a year or 2 years. And I think very roughly you could divide those changes onto 2 axes. On the one hand, how do we get better results? New kinds of model, agents, multi-agents, multimodal, multi-agentic, RAG, all sorts of cool new acronyms. How do we get better results? And on the other hand, could they please make this stuff cost a bit less fucking money? So can we work on the training cost, the inference cost? Should we optimize our model for training or inference? How do we get the models to be smaller? This, I think, exemplifies the problem. This is the CEO of Anthropic saying, we're spending $1 billion to make models now, and then in a year or 2, we'll spend $5 billion or $10 billion or maybe more. This doesn't remind me at all of when I was a baby analyst listening to people talking about building internet companies in 1999. No parallels whatsoever with that kind of model. Meanwhile, another great model memo from this time last year, just as ChatGPT is really taking off, someone inside Google wrote this, saying we have no moat. This is a commodity technology. It's all open. It's all public. There's no technology barrier. There's no network effect. And in particular, open source is going to change everything. And that turned out to be pretty much true. What happened in the course of the last year is that OpenAI launched their model. Everyone's head explodes. Google, Meta, Microsoft, Amazon rushed to launch their own models. Of course, many of them already had those models. And we've got kind of a wave of billion-dollar startups. For some strange reason, last week, some people even gave Elon Musk another $5 billion to build another AI company. And meanwhile, of course, open source, driven by Meta, has set a level for the whole industry. There's a great quote from the past that everyone in tech is giving someone else's business a model away for free. That's kind of what Meta is trying to do right now. They're trying to turn generative AI into commodity infrastructure, just as happened with data centers in the past. And so if there's no fundamental moats, no fundamental differentiation in the models themselves, there's no kind of fundamental technology barrier, then right now the moat is capital. How much money can you raise and how quickly can you spend it? And the quickest way to spend the money is to give it all to NVIDIA. In fact, it might just save time if the VCs and investment funds just wired the money directly to Jensen. And so we have this astonishing growth rate in NVIDIA's revenue, now at a $100 billion run rate. Something like 80% of all data center compute spending is now going to NVIDIA. And meanwhile, Intel's revenue has fallen off a cliff. And about 40% of that is going to hyperscalers. And the hyperscalers you can see here, again, their capex will probably go up by about 1/3 this year, and the big 3 will spend something around $150 billion building data centers just in 2024. So we have this surge of capital and this surge of construction. What we also have is kind of an interesting swing. In the tech industry tends to move in platform shifts. Every sort of 15 years or so, there's a new fundamental platform, and that's what all the investment and all the company creation, all the innovation is around. And so that was mainframes, and then PCs, and the web, and then smartphones. And each of them were also a swing back and forth from the edge to the center. With the web, when we went from the web to smartphones, we went back to the edge. Now, with all of these cloud models, we go back to the center. What do all those models in the cloud look like? Well, we're kind of in the feeds and speeds phase of the market. Anyone who isn't familiar with this phrase, remember in sort of 2010, when everybody knew how many cores their smartphone had and how much memory and how big the screen was and how good the camera was, and now nobody cares. That was also where PCs were sort of 20 years ago. How many gigabytes of RAM? How big was your hard disk? What kind of sound card did you have? And today it's, well, what's your context window and how many tokens and what's the price per token? The bottom line of all of that, I think, is that we've obviously had a price collapse and an increase in, so we've had a price collapse much greater than the increase in capability. But what we also have, which I think is very interesting, is this split between what you can get at what the cutting edge costs and what you can get if you're willing to take just a little bit better, a little bit lower capability. So you can get sort of 75, 80, even 90% of the cutting edge for about 10% of the cost. And that's driving an awful lot of thinking around open source, around servers, around what product development might look like. Meanwhile, again, there's another famous quote, way of thinking about tech: better, faster, cheaper, pick two. And right now we're thinking about what those trade-offs are, because the last time that you actually had to think about marginal cost was sometime in the 1970s. Most people in tech weren't born the last time you had marginal cost every time the user pressed OK. And yet now you actually have to think about that if you're building any kind of scaled machine learning, scaled LLM product. And so that gets us to a set of trade-offs. All of those model providers now have sort of 3 to 4 models at different brackets. There's the frontier science model that produces the best possible results, damn the cost. There's your production model, which is almost as good and not quite as expensive. Then there's whatever you can make that's kind of smaller and cheaper. And finally, and this is where kind of all the excitement is going to be next Monday in Cupertino, is what can you do on the edge? What can you squeeze onto a PC or onto a phone? Because I use these numbers of hyperscaler capex and then the amount of money that's going to NVIDIA. But meanwhile, consumers buy $400 billion of smartphones, and then the PC market is another $200 billion every year. And that's an awful lot of compute that your users have already paid for that you don't have to check, that doesn't give you marginal cost. If you can get the models to run on a phone, then suddenly you don't have a bill from OpenAI or from Google. Hence, we saw the announcement last week or 2 weeks ago from Microsoft of a hybrid model of having small models on the PC, larger models running in the cloud. Apple, of course, has been shipping local NPUs, local machine learning accelerators in their own silicon for close to a decade now. Every iPhone, every Mac, every iPad out there more or less has custom silicon to do this. And so that's where Apple's announcements at WWDC next week are very likely to be focused. Let's try and get some of this onto the device rather than running it in the cloud. Meanwhile, so that's kind of sort of some sense of the rush to models. On the other hand, we have another set of questions. Everyone's heard about hallucinations. Everyone's got their favorite way of describing it. The bullshitting undergraduate, the overconfident lawyer, whatever you want to call this. This is my favorite recent example. Air Canada built a chatbot to give customer support. A customer asked what the refund policy was. The chatbot gave them a refund policy. It wasn't Air Canada's refund policy, but it was a good refund policy. Customer went to court, and the judge said, no, you do actually have to honor this. And the challenge here is that when we ask these systems to answer a question, that's not really what they're doing. They're not databases. Rather, what they're doing is they're matching a pattern. They're saying, what do answers to questions like this tend to look like? And that's quite difficult to understand, and it can be quite deceptive when you use these systems because the text generation is so good that hides the fact the model behind it might be wrong. This is a survey that Deloitte did last year and then this year. And the fascinating thing here is that people who have used ChatGPT are more likely to think that it's never wrong, because the way the product presents the answers is so convincing. It looks like it's always accurate. And you have to kind of play with a little bit more to realize, no, that's not really what this is doing. The challenge here, I think, of course, is what do we do about this? And the obvious answer is, well, you just make the models better. I was actually at an event a couple of weeks ago where someone in the audience said, well, why don't you just tell the model not to be wrong, which would be a great idea if unfortunately, that's not how statistics work. More useful, I think, is to ask where this matters. What are you doing with this? And there are some domains where the answers are really easy to see, where it's obvious that that bit's wrong, and so it's relatively easy to fix it. More interesting to me, I think, is there are domains where there isn't really a wrong answer. There are some domains where give me something that looks like the right answer is bullshit. And there are other domains where give me something that looks like the right answer is exactly what you want. So this is kind of a nice illustration. I asked Midjourney to give me a fantasy 1960s French sports car. And this is a sports car. It looks French. The building looks French. It looks 1960s. It's got kind of a Citroen vibe. It also has 2 steering wheels and no door. Is that lying? Well, no, not really. Does it matter? Well, it depends what you wanted it for. If you were brainstorming for a movie, well, you're not going to use that, but it's a brilliant concept for what the car could look like. And so the question of whether the error rate, what the error rate means, is this hallucination, is lying, is as much a question about is as much a problem of what question you ask, rather than a science problem. It's a use case problem and a product problem as much as a science problem. Now, taking a step back, those are kind of 2 of the questions that we're wondering about, the model size and cost and hallucinations. There's a lot of other issues that people are wondering about, asking questions about, including a kind of a small cult of people in the Berkeley Hills who think this is all going to kill us all. But meanwhile, I wanted to just go back to this quote from Bill Gates. And I said it's interesting what he doesn't mention. He doesn't mention PCs. He doesn't mention the internet. He doesn't mention mobile. And the thing I think he's getting at here is that the GUI was a huge change in who could use software, because now you didn't need to learn the command line. You could just click on what you wanted. But someone still needed to make the thing that had a GUI. Someone still needed to create that software. Whereas you could go to ChatGPT and ask it to do a thing without anyone having to create a dedicated tool. So a GUI means you can create more tools. And so that's a huge change in what can be automated. And an LLM might mean far more things can be automated without anybody needing to create any more tools. And so that gets us, I think, to a couple of different models for how all of this might actually end up being deployed. There's a base case that says it's more features. It's API calls. It gets integrated into the software you use. It's used to create new features. This is what Apple will be announcing next week. This is autocomplete. A little bit more interesting is to say, well, this lets you create whole new kinds of tool that you couldn't have built before. It lets you automate new classes of problem. And then you have the kind of the wild-eyed utopian idea, more that you can just get this thing to do anything, that you can get it to automate an entire workflow, an entire process, an entire job, organize this entire conference. Will that work? We'll see. Check back next year, 2 years, 3 years, we don't know. But if we step back a little bit further, and think about what this is all going to mean for the rest of us, I kind of was reminded of this quote from The Godfather. If anything in life is certain, it's that you can kill anyone. And I think if we apply this to technology, if anything in technology is certain, semiconductors are cyclical, markets respond to scarcity by increasing supply. If technology is a commodity, then it will get cheap. And that seems quite likely to get applied to generative AI. One more observation, incidentally, is that every new technology tends to produce a bubble. And this one won't be any exception to that. Meanwhile, of course, these are all the questions within technology, but we also have a bunch of questions outside technology. What does this mean for everybody else? And the first answer is, first of all, we should hire some consultants. Every CEO of every big company last year read about AI in The Economist on an airplane, and when they landed, they sent an email to all their direct reports saying, what's our strategy for this? And the strategy was hire Bain, BCG, or McKinsey. So BCG say that will be 20% of their revenue this year. Slightly more interesting, I think, is this quote from Accenture. On the one hand, they did $300 million of Gen AI projects. A little bit later on the same call, they also said they'd done 300 generative AI projects. And I don't have a maths degree, but I can divide 300 by 300, which tells you that they did an awful lot of POCs. Everybody has done a POC. Everyone has got a ChatGPT account. Nobody's actually got this into production yet, although we'll see what happens to the call center business in a year. And I think kind of conceptually what's happening here is that with every new technology, there's a sort of an S-curve. And to begin with, you try and work out what this is for, why is this useful. Very often, the new thing looks like a toy. It won't scale. It's kind of a silly thing for rich teenagers. That was smartphones or cars or aeroplanes or computers or the internet. Then there's a period when it's very exciting, and then there's a period when it's boring. Airplanes are boring now, smartphones are boring, machine learning is sort of halfway through that process, and generative machine learning is at the beginning. It's very exciting, but we're trying to work out what it's for. And I think a good way to conceptualize that is just to go back and think about how we went through that process with the last wave of machine learning, sort of 10 years or so ago. I would go to big companies, and I would show them demos like this from ImageNet. Machine learning means you can do this now. And they would say, well done, very clever. Like, why is this useful? What are we supposed to do with this? We don't have any images, and we certainly don't have any images of dogs. So what are we supposed to do with this? And we had to go through this process of working out the right level of abstraction. It's not just image recognition. It's a whole other class of computer science problem. And really what's going on here is this is pattern recognition. And so what can we turn into pattern recognition? And we spent the last 5, 6, 7 years building companies that said, hey, we've just realized you could turn this problem into pattern recognition, or even you could turn it into image recognition. And now that's become every software company in the last 5 years. We're now at the same process, I think, with generative machine learning. Instead of recognizing cat pictures, you can make cat pictures. OK, that's great. And there was a brief moment of excitement around generative search. You know, imagine you're going away on holiday, what should I do? And instead of opening 20 tabs in Google, you can just ask ChatGPT the answer, and it can tell you. Maybe. We'll see what that means. But we kind of have to, we're still trying to work out, well, what's the right conceptual level to understand what this thing is doing? You can say something that sounds clever but is actually stupid, which is to say it's just predicting the next word. You could say this is pattern creation, which is technically true, probably, but a little bit too limited. Is this synthesis and summary? Is it a reasoning engine? Well, not yet. Something else? We're not sure. But meanwhile, you have to ask, well, what is it that we can do with this? There's an old joke about the Frenchman who says that's all very well in practice, but does it work in theory? And you can spend too much time thinking about the theory of it and working out what you can do. And I always thought kind of a good way of thinking about the last wave of machine learning was to say that this gives you infinite interns. So you would like to listen to every call coming into the call center and tell me if the customer is angry. You'd like to look at every credit card transaction and tell me if there's something weird about that. You would like to paint out every photobomber in every photograph you took in the last 10 years. Well, you could get an intern to do that, but you could never automate it. And now you can. And the new wave of machine learning, I think, gives us another kind of wave of applications of this. Put simply, every text box on the internet is getting an LLM. You would like to write some generic and slightly nauseating self-promotion content for your LinkedIn profile because there isn't enough of that. Well, you could get an intern to do it for you, or now you could use an LLM to write nauseating self-promotion content. A little bit more useful, this was a case study from Amazon from last year. Let's make it easier for people to create more interesting product shots. So you take your generic picture of a toaster, and then you put it in a bunch of different kind of practical scenarios. Fun thing about this, incidentally, is that we've now put a toaster on a towel. So as soon as you toast something, you're going to start a fire in your kitchen. This is, I think, the perfect example that this is an intern. Like, you get the intern to do the work, but then you check it. And I think what happened in the course of 2023 is we've had a really big adoption in two early and obvious places. Huge adoption in code assistants on the one side. In fact, if you just go and Google AI code assistant, you just get an endless scroll of hundreds of these things. And on the other side, marketing. So this is a screenshot from WPP's Investor Day. They built a whole internal dashboard to give all of their internal teams access to a whole bunch of different LLMs, different generative models. And those can be trained on different brand, different tone of voice, different target demographics, different approaches, so that you can generate ideas. And the scenario here, as I sort of mentioned earlier, is on the one hand, it's easy to see the mistake. And on the other hand, there isn't really a wrong answer. You're just looking for a bunch of ideas. And I think what's kind of happening here conceptually is that every time you have a platform shift, a couple of things happen. Indeed, a pattern happens. You could ask ChatGPT to explain it. So the first thing that happens is the incumbents make it a feature, and so that's what we see from LinkedIn. It's what we've seen from Adobe. It's what we see with Google and Microsoft spraying LLMs all over their products. Then you start to see startups using it to unbundle. Startups unbundle some aspect of Oracle or Salesforce or Excel. And a little bit further on, somebody will work out ways that you can use this technology to fundamentally change the nature of the market, to create some completely new thing. And there's nothing new about this. This is a process that happens every time you have a new technology. So this is a still from a movie called The Apartment from 1960. Jack Lemmon is a clerk in an insurance company. He's in the middle row, in the second row. Everyone here has a typewriter and an electromechanical adding machine. And so everybody here is basically a cell in a spreadsheet, and the whole building is an Excel file. Once a week, someone on the top floor presses F9, and the whole building recalculates from top to bottom, and kind of generates new insurance prices. And then in 1965, they bought a mainframe. They threw away all the adding machines. And to begin with, the mainframe just automated the stuff they were already doing. And then over time, that allows them to run the business in completely different ways. The same thing with PCs, the same thing with networks, the same thing with mobile, with smartphones, and now with AI. To begin with, you make the new tool fit the way you already work, and then over time, you change your work to fit the new tool. And so as big companies are deploying this technology, and indeed as they were deploying each of those previous ways of technology, they kind of have to ask themselves, well, are we looking for top-line innovation or bottom-line innovation? Because the easy, obvious thing you can do with this is to save some money. You can automate some programmers, you can automate some production work, you can automate some marketing. And so the first thing that everyone's been talking about is cost saving. You save a few points of margin. But then you push a little bit and you think, well, how is it that this could automate something or enable something we couldn't do before? How might this change the product? And then again, you push further and say, how can this change the market? How can this actually create new ways of doing what we're trying to do here? Something implicit in this slide is that this might take a while. It might take a couple of years. And I think a good illustration of that is to think about how long it's taken for big companies to adopt cloud. If you work in tech, then cloud is old and boring and done, and that happened years ago. But in actual big companies, we are still only at sort of 20 to 30% adoption of cloud. And the CIOs always think it's going to be 10 or 20% higher in 3 years, but somehow they never get there. It takes a long time to fundamentally change how things get done. It took a long time to deploy PCs and mobile and the internet. It will take time to deploy all of this stuff. And as you go through that process, what you're really talking about is not AI and the next industrial revolution. You're talking about this wonderful, horrible phrase, digital transformation. And I always say that when you say digital transformation 3 times, a partner from Accenture will appear in the room in a puff of smoke and offer you a contract. And that's kind of, it feels like a parody of marketing bullshit, but what it actually means is in the 90s, big companies went from mainframes to PCs, and now they go from PCs and on-prem databases to the cloud, and the way they run their companies changes as a result of that, and that takes time. And you have very basic questions like, do we build our own? Do we go to a startup? Do we go to Microsoft? Do we go to IBM or Oracle? Do we have one vendor, lots of vendors? Where do we deploy it first? How do we work out? Which teams should use it? Should it be a corporate center function, or should we put it out into the opcos? And then, of course, the most important question of all, whose budget does this come out of, and what financial year? And can we wait until we fully depreciated our existing on-prem software purchases? So these are not technology questions. These are the kind of the boring, mundane realities of how companies actually deploy software. But when you go through that process, where you end up is you have massively more software. The average big company today has something between 400 and 500 SaaS applications deployed. All of those unbundling some aspect of Excel or Oracle or Salesforce or email and turning it into some dedicated vertical application. And that's kind of the same way that we should expect generative AI to work as well. Maybe. So it sometimes seems to me that you can divide all questions about AI into one of two categories. The answer is either it will work just like every other platform shift. How should we, as a large manufacturing company, work out what our generative AI strategy should be? Well, how did you do that for cloud or mobile or the internet? It's the same thing. It's a platform shift. The other kind of answer, like, is this going to kill us all or will agents work, is no one knows. Actually, no one knows. So the answer is either these questions either have very easy answers or the answer is there is no answer. But pulling back one step further, this is a great quote from the 70s. AI is whatever doesn't work yet. Because once it works, people say, well, that's not AI, that's just software. Today, when you got into this, this building and you got your pass, you didn't say, I'm going to use a database now. It's not exciting or magical, it's just software. In the 1970s, databases were AI. They were literally AI. That was what people were working on to build AI. They were using databases. Today, it's just software. And so by default, come back in 10 years' time, this won't be AI, this will just be more software. And of course, the computer can do all of that stuff. It's boring. Meanwhile, it's worth stepping back a little bit further and saying that all the stuff we were excited about in tech in September 2022 is still there and still happening and still driving trillions of dollars of spending. And one of the ways I try and think about this is that there's a sort of a time lag. That's to say the tech industry is very excited about what's going to happen in 2025 or 2030, which now mostly means generative AI. If I'd been here 2 or 3 years ago, I would have had to pretend to be interested in crypto and metaverse. Obviously, nobody here was interested in crypto and metaverse, but there were other people who thought they were going to be a big deal. We don't talk about that anymore. Meanwhile, most actual software companies today are deploying ideas from 2010, ideas like SaaS and cloud, workflow, automation, collaboration, Google Docs but for video, Google Docs but for this. And then outside of the tech industry, the rest of the economy is being overturned by ideas from 2000, ideas like maybe people will watch video on the internet, like wild, crazy ideas like people might buy clothes on the internet. That was like a really crazy idea. No one was ever going to do that. And if we think about what that chart looks like, I didn't make this chart until 2020 because it was the most boring chart in the tech industry. It just goes up 1% every year. We went through this little blip in the pandemic, and now we're more or less exactly back onto the trend line, but we're on the trend line at 20, 30, 40%, depending on where you are. And that means we have some pretty profound changes in consumer behavior. I think everyone in this room now will have heard of Shein. Shein probably did $45 billion in GMV last year, which makes it double the size of Zara or H&M, who basically invented fast fashion. It also means it's probably the largest pure-play fashion retailer on the planet. There are other people who sell more clothes, like Amazon and Walmart, but if you're looking at people who just sell clothes, Shein might actually be the largest apparel retailer on Earth today. And then there's this thing called Temu, or Temu, I need to find out which is probably on track to do roughly the same this year. And so when you have new channels, when you assume that everyone is online, you have these new fundamental kinds of businesses getting created. Another company that's been riding that trend is Shopify, which did close to $150 billion of GMV last year, so it's close to half the size of Amazon Marketplace. And then we have some companies that really did benefit from the pandemic. So, for example, Instacart had this astonishing explosion as it went through lockdown and has held on to that business, and it's still growing nicely. But the interesting thing about Instacart's business, or one of the interesting things about Instacart's business, is that almost all the profit actually comes from advertising. So this shows you Instacart's free cash flow and then the ad revenue, which is basically all margin. There's not very much incremental cost to doing that. So Instacart is basically an ad business with grocery delivery attached. Amazon, of course, pioneered this. Amazon did about $47 billion of ad revenue last year, and that reflects this broader segment that people are calling retail media, which was something over $100 billion last year and growing really, really fast. Amazon's $47 billion of ad revenue, incidentally, means it's roughly double the entire global newspaper industry, which is an interesting shift in how people think about products and how people decide what they're going to do with themselves. Meanwhile, the other industry that's been going through a big change is the TV industry. And as I think most of us are aware, TV had peak television, as we had this enormous surge in the production of TV content that's now collapsing back down as TV companies discover there's this thing called churn, and that maybe it would be nice to make a profit. On the other hand, the music business, which was probably the first industry to be affected by the internet, has actually returned to growth and is now back up to about 75% of the peak. It's quite possible it will grow even further. And then one more company to look at, Uber, is not only now at a $145 billion run rate and has shifted from being rides to being half rides and half delivery, but is even sort of profitable, which a lot of people thought was never, ever going to happen. Regulators, meanwhile, as ever, most predictably of all, are still arguing about things that we stopped arguing about 15 years ago. And so one way that I would kind of try and pull those threads together as the out-of-time light flashes at me and you all wonder when you can go off for lunch, as I think about all the things that I've been talking about, technology has changed how those industries worked, but all the questions are not really tech questions. All the questions for Netflix or for the TV industry now are TV questions. They're not technology questions. The same thing for Shein, the same thing for the car industry. Technology has changed how the car industry works, but all the questions are now car industry questions. And I think a good way to think about that as you go out to lunch is to think about the last time this happened, which might be the car industry. The first 50 years of the car industry, you could say, was what's a car? What's a car company? Who's going to have a car? How does this work? And the second 50 years was what happens when everybody has a car. How does that change everything else? And it creates Walmart, McDonald's, freeways, Best Buy, shopping malls, and all sorts of other things. The same thing now with software. The first 50 years of the software industry was what's a computer? Why would you have one? How does this work? What's a smartphone? The second 50 years is what happens when everybody is online, and that gets you Shein, and it gets you Netflix, and it gets you Shopify, and it gets you lots of other trillion-dollar businesses, all of which are enabled by software, but they're not really software companies anymore. And with that, I will say thank you.
There you go.